let's discuss continuous functions. Suppose we have two functions f and g that are continuous on the same set. In particular, let's suppose that set is the interval from a to b inclusive. The question we want to answer is whether their sum, whether f plus g, is also continuous on that same interval. The answer is affirmative, yes. To see this, we are going to employ an epsilon delta argument. So let epsilon be greater than 0. And let x0 be an arbitrary point within the interval AB. In our argument, we consider the case where x0 is within the interval. Now, here is what we want to show. We want to show that there exists a delta greater than 0, such that if the difference between x and x0 is less than delta, then the difference between f plus g evaluated at x and f plus g evaluated at x0 is less than epsilon. So we want to show that there exists a delta greater than 0, such that if the absolute value of x minus x0 is less than delta, that implies that the absolute value of f plus g evaluated at x minus f plus g evaluated at x0 is less than epsilon. So we begin with what we have. What do we have? We have that f is continuous at x0 and that g is continuous at x0. What does this mean? By definition of continuity of f, there exists a delta, call it delta 1, greater than 0, such that if the absolute value of x minus x0 is less than delta 1, that implies that the absolute value of f of x minus f of x0 is less than epsilon over 2. Our choice, epsilon over 2, will become clear as we progress in the argument. Now, similarly, by continuity of function g, there exists a delta 2, greater than 0, such that if the absolute value of x minus x0 is less than delta 2, that implies that the absolute value of g of x minus g of x0 is less than epsilon over 2. Now, how can we obtain our goal? If we look at our current inequalities, we realize that we we'll obtain our desired inequality from these two if we rewrite them as compound inequalities. But we have a problem. These conditions depend on how far apart x and x0 are. Delta 1 and delta 2 could be different. So how can we ensure that both of these conditions are satisfied? We are going to have to ensure that x and x0 are close enough to each other. So to that end, let's define delta to be the minimum out of these two, delta 1 and delta 2. So let delta equal to the minimum value out of delta 1 and delta 2. What happens? If the absolute value of x minus x0 is made to be less than delta, it automatically is less than delta 1 and delta 2. So that means that both of these conditions will be satisfied. So if the absolute value of x minus x0 is less than delta, that implies that the absolute value of f of x minus f of x0 is less than epsilon over 2, and also the absolute value of g of x minus g of x0 is less than epsilon over 2. So now, let's write each of our inequalities as compound inequalities and combine them. So the first inequality gives that f of x minus f of x0 is less than epsilon over 2, and it is greater than negative epsilon over 2. We also get that g of x minus g of x0 is less than epsilon over 2 and greater than negative epsilon over 2. Now, what we need to do is we need to add those two inequalities. So, when we add, in the middle, we get f of x plus g of x minus f of x0 minus g of x0 Now that's less than epsilon over 2 plus epsilon over 2, which is epsilon. And at the same time, that is greater than negative epsilon over 2 plus negative epsilon over 2, which is negative epsilon. And as mentioned earlier, now we know what we picked, epsilon over 2. Okay, now, at this point, how far are we from our goal? We are not too far. What we need to do is we need to rewrite this current compound inequality as an absolute value inequality, and we will be matching that. Now, let's factor out this minus in here because we want this sum right there. So let's put the minus outside. We're factoring it out. So now we just rewrite this as an absolute value inequality. So we get that the absolute value of f of x plus g of x minus the quantity f of x0 plus g of x0 is less than epsilon. Let me repeat that. What do we get? We get that the absolute value of f of x plus g of x minus the quantity f of x0 plus g of x0 is less than epsilon. Now, is this our goal? The answer is yes, because remember that f of x plus g of x is the same as f plus g evaluated at x, and f of x0 plus g of x0 is the same as f plus g evaluated at x0. So we have achieved our goal.